All right, so after looking at valence electrons, then it makes sense to talk about ion configurations and how the configuration changes when electrons are lost or gained. So our rules for ion formation are that ions will always lose valence electrons from the energy level furthest from the nucleus first. So this means it will lose from the S sublevel first before it would lose from the D sublevel. So it doesn't follow the Aufbau principle based on energy. It follows the idea that 4s, for example, would be further away than 3d, and so those electrons will be lost first. Ions that gain electrons will add the electrons to the shell that isn't filled, so it will be adding electrons to the p sublevel. Let's go ahead and do an example together. So let's look at sulfur, which has 16 electrons. I'll go ahead and draw out my orbital diagrams for sulfur. So I would have 1s, 2s, 2p, 3s, 3p. Now keep in mind, I'm going to add 4s even though I don't need it, but keep in mind that as you do this, you might end up with more, or you might have to add some orbitals as you go, but as you become more comfortable with everything, you'll be able to fill it all in nicely. So we look at sulfur, so it has 16 electrons, so we'll follow Hund's rule and Pauli exclusion principle where they are going to be in opposite directions, so 1, 2, 3, 4. We'll follow Hund's rule where they don't pair up until they have to, and so that's 10, and we'll follow the Aufbau principle where they fill up in order of energy. So we have 10, 11, 12, 13, 14, 15, 16. All right, so if we look at these, our highest principal energy level is 3, and so these are our valence electrons, and so we have 6 total valence electrons. Now what we talked about before, it's going to be easier to gain 2 electrons than it would be to lose all 6, and so we will, whenever we have this and we form an S2 minus ion, then we will gain these last 2 electrons. Our electron configuration then would be 1s2, 2s2, 2p6, 3s2, and 3p6. Now, what we find is that this will be the same configuration as argon, which is the next closest noble gas. And so it gains those 2 electrons, and it then has the same configuration as argon. Here's another example for sodium. And so with sodium, we have 3s1 as the valence electron, so we have 1 valence. And with this, sodium will lose that 1 valence electron, and it will have the configuration 1s2, 2s2, 2p6. This will be the same as neon's electron configuration. And this, we talked about how ions strive to be close to the noble gas, so they gain or lose valence electrons to become closer and more like that. So why does the loss of the electron not make sodium become neon? And this is because sodium still has the same number of protons, and protons are what identifies the atom and the element. So why don't you go ahead and do 2 examples. So we have lithium and oxygen. Go ahead and write the normal electron configuration or the orbital diagram, and then go ahead and modify it to make the ion. You can go ahead and pause the video and then check your answers. So here's your answer for lithium +1 and oxygen 2-. All right, so let's talk about rules for transition metals. And so transition metals will form multiple ions in most cases. They will lose their outermost electrons first. So in these cases, they're going to be losing the s electrons first. Some ions will form additional, or some atoms rather, will form additional ions by losing the s orbital and then also losing the d orbital. All right, so here's an example. We talked about iron before and how iron can form +2 and +3 ions. So I gave you the normal configuration, and what you should see is that we have 2 valence electrons, and then we have 6d level electrons that are higher energy but closer to the nucleus. All right, so to form the 2+ ion, what we're going to find is that we will lose these 2 valence electrons, and so we'll have 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d6. Now the other option is that we can also lose d-level electrons. We'll lose these in order to make it more stable, so it's more stable whenever it is half full or completely full. And so in this case, what we find is that to form the iron 3 or the ferric ion, we will lose the 4s2, and then we will also lose 1 from the 3d level. And so what this means is that we'd get 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d5. And so we've lost from the S sublevel and the D sublevel to make something more stable. Please let me know if you have any questions.